Hello, everyone. Let's start with the explanation of our first chapter, chemical reactions and equations. So, in this chapter, we are going to learn about what are chemical reactions, how do we write chemical equations, and how do we balance them and why to balance them. We'll also talk about different types of chemical reactions. And finally, we'll talk about the effects of different types of chemical reactions in our daily life. So let's get started. So, what do you mean by chemical reaction? By definition, if any substance undergoes chemical change, we'll call that process as chemical reaction. Now, in 9th standard, you must have learned about something called as physical change and chemical change. So, we have a slide here in which, for example, you can see an omelette is cooking in a pan. Now, when we make an omelette, we can't convert back that omelette into an egg. It is not possible, which means this is a permanent change. It is an irreversible change. This type of change, when a new substance is formed, is called as chemical change, as you've learned last year. And when substances undergo such chemical change, we call this particular process as chemical reaction. So, cooking is a good example of chemical reaction. Whatever we cook, mostly it is irreversible. On the other hand, physical changes are something which can be reversible. For example, if I convert an ice or rather water into ice when I keep it into freezer, it just solidifies. There is no change in the chemistry of the substance here. The formula of ice is H2O, but in the solid state, and formula of liquid water is also H2O, but here the physical state is liquid. That's the only difference. There is no change in chemistry. On the other hand, whenever a substance undergoes chemical change, we get a new substance which will have completely new properties. For example, just to clarify, how is water formed? Water is formed by reaction between hydrogen and oxygen. When they combine, we get water. We already know that hydrogen is a highly inflammable gas. Oxygen is required for the combustion reaction or for the burning process to happen. So, if you look at the properties of water, it has completely new properties. It is nor like hydrogen, neither it is like oxygen. If you put water on fire, it extinguishes fire. So it has completely new set of properties. So this is a chemical change. So there are a lot of reactions which happen around us, surrounding us, which are basically chemical reactions. In most cases, we don't pay attention to them. For example, cooking is one example I told you, or rusting of iron is another example, which is very common around us and which we don't pay much attention to. So this is what chemical reaction is about. Chemical reaction is a process in which substances undergo chemical change. How do we know chemical reaction has taken place? When we mix two substances, there is no hard and fast rule that both the substances have to react with each other. Sometimes they will react, sometimes they may not react. But if I mix two substances, substance A and substance B, let's say, how do I know that they are reacting with each other? For that, you can look for some signs. For example, here we have taken one reaction, or you can see one flask here. In this flask, we have got zinc granules or zinc metal, and there is, let's say, an acid like sulfuric acid. Let me write that properly. Okay, so the reaction is basically, let's say, zinc plus some acid like sulfuric acid. Now, when these substances react, you will see that there are bubbles in the flask or in the test tube. Evolution of bubbles means some gas is being released. In this case, the gas released will be hydrogen, is one sign which can tell you that the reaction is happening. Or the flask becomes hot, warm. If you touch the flask, if you touch this test tube from outside, you will feel the heat, which is one more sign which is telling you that chemical reaction is happening. So change in temperature, okay, change in color. Sometimes some reaction, if you mix two reactants, you will see that there is change in color. Sometimes there is some smell released or odor, okay, that will also tell you that there is some kind of chemical reaction happening. So change in temperature, change in color, some smell being released, or bubbles in the test tube, all these are the signs which show you that the chemical reaction is happening. If you don't see any sign, if no bubbles are formed, if the temperature isn't increasing or dropping, if there's no gas release, if there's no color change, maybe the substances are not reacting with each other, which is also possible. Now let's take an example and try to understand how to write a chemical equation. Let me write a very simple chemical equation. Let's say hydrogen reacts with oxygen to give water. As you can see, I have written symbols for all the reactants and products. On the left hand side, we know that we write reactants. Again, what are reactants? Reactants are those substances which undergo chemical change. And on the right hand side, we write products. Products are new substances formed during a chemical reaction. If there are more than one reactants or more than one product, what do? We put a plus sign in between, as you can see. The arrow in the equation that I have shown here shows the direction in which the reaction is proceeding. But this is not a complete equation. There are a few more things which we can add here. We also write the physical states in which reactants are used or in which products are formed. For example, in this case, hydrogen is used in the gaseous form. So into brackets, I can write G. Oxygen is also used in gaseous form. So I'll write G into brackets. We get water in liquid form. So I'll write L. If you get a reactant or product in solid form, you can simply write S into the brackets after the reactant or the product. If it is dissolved in water and used, we write aqueous, which is into the brackets, we write AQ. So these are physical states of the reactants and products that we include in a chemical equation. We also write the physical conditions required. Sometimes you require sunlight, sometimes you require maybe some temperature, maybe pressure, maybe heating. All such physical conditions which are needed for reaction to happen, those are normally written above and below the arrow. For example, let's say we require heat here, then I'll write heat above the arrow or below the arrow, which will tell us that this reaction needs heat. So any physical condition again will be written above or below the arrow in a chemical equation. So is this reaction or is this equation complete? It is not still complete. There's one thing missing, and that is called as balancing the chemical equation. So let's understand what is balancing chemical equation and why do we need to balance a chemical equation. Now, the last step of writing a chemical equation is to balance the chemical equation. First of all, let's understand why do we need to balance a chemical equation. Last year, you must have learned something called as law of conservation of mass. As per law of conservation of mass, we know that mass can neither be created nor it can be destroyed in a chemical reaction, which also means atoms can neither be created nor they can be destroyed. Atoms, individual atoms, have mass, as we have learned last year. So if I don't have same number of atoms on both the sides of the chemical equation, then I'm violating the law of conservation of mass. For example, if I look on the left hand side here, I have written an unbalanced chemical equation. If I look very carefully, I have 2 atoms of hydrogen here. I have 2 atoms of oxygen. So on the left hand side, I have got 2 atoms each of hydrogen and oxygen. But if you look at the products, I have 2 atoms of hydrogen, but there is only 1 atom of oxygen. So in total, I have 4 atoms on the left hand side, whereas on the right hand side, I have just 3 atoms. If I leave this equation as it is, I'm violating the law of conservation of mass. So to avoid this violation, to make the number of atoms equal on both the sides, we'll have to balance a chemical equation. So on the right hand side, you can see I have shown the balanced version of this equation. If I put a number 2 here, I get in total 4 atoms of hydrogen on the left hand side, and on the right hand side also I get 4 atoms of hydrogen. If I put 2 in front of water, then I have got 2 oxygens on the left hand side and 2 on the right hand side. So this completes the balancing process, or this basically is called as a balanced equation. But how do we achieve this? Let's understand the process of balancing equation. So let's take another example and try to understand how to balance a chemical equation. Suppose I write an equation here. Iron reacts with water to form Fe3O4 plus hydrogen. Now this is an unbalanced reaction, which means it needs balancing. How do I know it is unbalanced? Basically, I'll have to count the number of atoms for every element on the left hand side and on the right hand side. So let's do it. For example, in this case, I have got 1 atom of iron on the left hand side, but I have 3 atoms of iron on the right hand side. Number of hydrogens on both sides are 2 each, so that is balanced as of now. Number of oxygens on the left hand side, I have got 1 atom of oxygen, and on the right hand side I have got 4 atoms of oxygen. So which means this particular equation is unbalanced. So how do I balance it? Basically, I have to get same number of atoms on both the sides, on the left hand side and on the right hand side for every element. So let's start with the first element, iron. I have got 1 on the left hand side and I have got 3 on the right hand side. Remember, I cannot reduce higher number, that is 3, which is on the right hand side, to 1, but I can make or convert this 1 on the left hand side into 3. How do I do it? I'll put number 3 in front of iron. So this gives me 3 iron atoms on the left hand side and 3 iron atoms on the right hand side. Let's move on to the next element. Hydrogen is already balanced. Oxygen is 1 on the left hand side and 4 on the right hand side. Again, I cannot reduce this 4 to 1, but I can increase 1 to 4. How do I do it? I put 4 in front of water. Remember that while balancing any chemical equation, you can't change the formulas. So if you are getting confused for balancing purpose, what you can initially do is basically you can put boxes for every reactant and product. And when you put a box, you are not supposed to write anything inside the box. because when you write anything inside the box, you will change the formula of that particular substance, which you are not supposed to do. Whatever numbers you are putting for balancing, those are supposed to be in front of that box. And when you put the number in front of the box, it is applicable to the entire box. So now when I have put this 4 in front of water, it is applicable to the entire box. So I got 4 oxygens on the left hand side, 4 oxygens on the right hand side. But because there is hydrogen in the box, this 4 is also applicable to hydrogen. So now I have in total 8 hydrogens on the left hand side. 4 into 2, that's 8 hydrogens. Which means on the right hand side, I have to increase number of hydrogens from 4 to 8. Sorry, 2 to 8. Right now there are 2. I need to make it to 8. For that, I'll put simply number 4 in front of hydrogen on the right hand side. So that gives me 4 into 2, 8 hydrogens on the right hand side also. So now if I check every element, I've got 3 iron on the left hand side and 3 ions on the right hand side. 4 into 2, 8 hydrogens, and 4 into 2, 8 hydrogens on both the sides, and 4 oxygens and 4 oxygens on left hand side and right hand side. So this is completely balanced equation. So that is how you're supposed to balance the equation and stick to the law of conservation of mass. So that was the part 1 of the first chapter, chemical reactions and equations. Don't forget to check out the second part of this chapter. I'll leave a link in the description below, or at the end of the video I'll leave the link also. You can check out the second part. Also, if you have liked the video, please subscribe to the channel. Thank you so much for watching.